Good morning, guys. Let me discuss about the organometallic compounds and the Word's rule calculus. I'm Dr. S. Anitha, Assistant Professor in Chemistry, Trinity College for Women. From this video, we learn about the what is organometallic compounds, what are the compounds in present of diborane compounds, how to calculate the closonido-arachno type of compounds. Let me introduce the outline of the topic. We discuss about organometallic compounds, polyhedral boranes, Bird's rule, and also heteroboranes. What is meant by organometallic compounds? Organometallic compounds are those compounds in which central metal atom are directly bonded with the carbon atoms of hydrocarbon radical or molecule. The bonding is ionic or covalent, delocalized between organic groups and a metal atom. Organometallic compounds, an area which bridges organic and inorganic chemistry, a branch of coordination chemistry where the complex has one or more metal carbon bonds. The metal ligand interactions are mostly biacid type. Metal carbon bond can be a sigma type or bibond type. Polyhedral boranes. Electron deficient species possesses fewer valence electrons than are required for a localized bonding scheme. Its an cluster atoms form a cage-like structure. There are a great number of known neutral and anionic hydroborane clusters. These structures are often described as being polyhedral or deltahedral atoms. That is a structure of diborane compound. It has the two 3 center 2 electron bonds. Higher boranes are prepared by pyrolysis in vapor phase method. So these are the structure of different types of borane compounds. Delta cages with 5 or 12 vertices. So here trigonal bipyramid, octahedron, pentagonal bipyramid, decahedron. So different types of diborane cluster compound are also available. World's role, a classification scheme for polyhedral borane. It's a scientist, Professor Kenneth Ward's FRS in 1971, who invented the Ward's rule calculation. He explained the classifications of structural types can often be done more conveniently on the basis of valence electron counts. What is Ward's rule? Determine the total number of valence electrons from the chemical formula. For example, 3 electrons per B and 1 electron per H. B means boron, H means hydrogen. Subtract 2 electrons for each boron hydrogen unit or carbon hydrogen in a carborane. Divide the number of remaining electrons by 2 to get the number of skeletal electron pairs, SEP. A cluster with n vertices, for example n borane atoms, and n plus 1 SEP for bonding has a glossal structure. A cluster with n minus 1 vertices, n minus 1 boron atoms, and n plus 1 SEP for bonding has a nido structure. A cluster with n minus 2 vertices, n minus 2 boron atoms, and n plus 1 SEP for bonding has a arachno structure. A cluster with n minus 3 vertices, n minus 3 boron atoms, and n plus 1 SEP for bonding has a hypo structure. If the number of boron atoms n is larger than n plus 1 SEP, then the extra boron occupies a capping position on triangular spaces. Naming polyhedral borane. So these are the different types of polyhedral borane. Well, let me remove the vertex once position to another one position. For in closo-borane, remove the one vertex, we get the nidoborane, and further remove the one vertex, we get the aragenoboranes. So these are the many of the examples of closo, nido, and aragenoboranes. It's a closo polyhedral borane structure. The number of pairs of framework bonding electron is determined by subtracting one boron hydrogen bonding pair per boron. The n plus 1 remaining framework electron pairs may be used in boron-boron bonding or in bonds between boron and other hydrogen atoms. That is another one examples B6H6 2 minus. Here the number of valence electrons 6 into 3 plus 6 into 1 plus 2 is equal to 26 electrons or 13 pair of electrons. 6 pair of electrons are involved in bonding to terminal hydrogen. Therefore, 7 n plus 1 pairs of electrons are involved in framework bonding where n is equal to number of boron atoms in a cluster. So these are the tabular column, electron count and name of the different types of boranes and predicted structure also. Here, these tabular column also different types of structures and their formula skeletal electron pairs. Closo comes from Greek word for cage structure. Nido is a Latin word of nest form. Arageno is a Greek word of spider form. Hypo is the Greek for nest form and glado is the Greek form of branch. So these are the different types of examples. Classify the following polyhedral boranes according to their valence electron count. So let me use this formula. We easily calculate the structure of B5 and H9 is an nidoform. B4 H10 as below a aragenoform and B2 H6 is a nidoform. So what is the structure of B6H6 2 minus? Let me use the formula easily calculate the name of the structure. Total number of valence electrons equal to 26 and the number of electrons for each BH units equal to 12. Number of skeleton electrons 14. So number of SEP is equal to 14 divided by 2 is equal to 7. So if n plus 1 is equal to 7 and n boron atom, so n is equal to 6. So that is the structure belongs to closo. So similar the what is the structure of B5H9? The structure belongs to nido structure. The what is the structure of B5 and H11? We use the formula, we get the arageno structure. So here heteroborane atoms, many derivatives of boranes containing other main group atoms also known. These heteroboranes may be classified by formally converting the heteroatom of BHX group having the same number of valence electrons. Considering the other atom in a context of Ward's rules, heteroatom carbon, silicon, gallium, tin replaced with BH and the heteroatoms nitrogen, phosphorus and arsenic replaced with BH2. Oxygen, sulfur, selenium can replace BH3. These represent in the most common main group heteroatoms incorporated into hydroborane clusters. So these are the examples. Easily calculate the heteroatoms is replaced on some of the groups. C2B7H13 is a arageno. Sulfur B9H11 is a nido. Carbon phosphorus B10H11 belongs to closo structure. Thank you guys. I hope you also get the good information how to calculate the Ward's rule, how in presence of the heteroatom, how to classify the Ward's rule like closo, nido and arageno. Thank you guys. Let me meet for another one very good video. Thank you.